linear equations. Okay, so reviewing finding the slope. So I gave you the formula. We have our points, -3, 4, and 2, -2. So if we plug in, we have m equals, what would y2 be? -2 minus 4, and then 2 minus -3. Could you switch those? Could you do like 4 minus -2 and -3 minus 2? You can switch the order of the y's as long as they're the same from each point. So this could be y1 minus y2 over x1 minus x2. As long as you're going in the same order, that's fine. You just can't do like y1 minus y2 over x2 minus x1. Okay, those ones and twos just have to match. Okay. Okay, what is -2 minus 4? -6. And 2 minus -3.
Negative.
And then we can't simplify that any further. That is our slope. Okay, so -6/5. Okay, and we talked about point slope form. So write an equation of point slope form. The line passing through the points 4, -3 and -2, 6. Then solve the equation for y. So what do we have to do first? Find the slope. So m equals. Okay, so what could we do on top? Okay, 6 minus -3, which means what would our denominator have to be? -2 minus 4. What is 6 minus -3? 9. -2 minus 4. Can we simplify that? It reduces to be -3 over 2, because they're both divisible by 3. Okay. Okay, for point slope form, does it matter which point we use? No. So there's two possible answers for the point slope form. Which one do you want to use? The first one or the second one? Pick, I don't care. Second one, thank you. So we have y minus y1 equals m times the quantity x minus x1. So if we're using the second point, we have y minus what? What's the y value of the second point? 6 equals the slope we found times the quantity x minus, -2, or switch it to be +2. So there's point slope form. How do we get into slope intercept form? We're solving for y. What do we have to get rid of? The parentheses. How do we get rid of the parentheses? Multiply, distribute. So y minus 6 equals -3 halves times x is -3 halves x. And then -3 halves times 2. So -3. Good. And then how do we get y by itself? Add 6. So y equals -3 halves x plus 3. Okay. Do we somewhat remember this? Okay. Then we graphed. And then we talked about Hoybucks, graphing horizontal and vertical lines. And do we have any other examples? Oh, application. Okay, so if we have a scatter plot, I'm not going to read that whole paragraph to you. Okay, so shown on the scatter plot is a line that passes through or near 6 points. Write the slope-intercept form of this equation using function notation. Okay, so you're just picking 2 points. It's giving you 2 points to use. Okay, so we have the point 326, 57.06 and 385, 57.99. Okay, so I'm going to rewrite those just so that way we can all see them. Okay, so whenever we're writing an equation of a line, what do we have to find first? Anyone?
Slope.
Slope. So m equals, okay, what are we going to subtract on top?
57.99 minus 57.06.
Correct, both of you. Over what? 385 minus 326. Okay, so if we subtract that, 57.99 minus 57.06 gives us 0.93. 385 minus 326 is 59. And if we go ahead and divide that, and let's round to the nearest, let's do 4 decimal places, 0.0158. Okay, so now we want to get into slope-intercept form. What is slope-intercept form? Y equals mx plus b. So we need to pick a point. Which point do you want to use? First or second?
Second.
Thank you. All right, so we have y minus, what's the y value? 57.99 equals 0.0158 times the quantity x minus, what's the x value? 385. Okay, we have y minus 57.99. Then we want to distribute. So we have 0.0158x and then minus 6.083. Then how do you get y by itself? Add the 57.99. So y equals 0.0158x minus 51.907. Okay. Questions with that? Okay. Okay, and last part. The pre-industrial concentration of atmospheric carbon dioxide was 280 parts per million. The United States Intergovernmental Panel of Climate Control predicts global temperatures will rise between 2 degrees Fahrenheit and 5 degrees Fahrenheit if carbon dioxide concentration doubles from the pre-industrial level. Compared to the average global temperature of 57.99 degrees Fahrenheit for 2009, how well does the function from part A model this prediction? So, yep. Okay, so we want to plug in 385 and see, no, that's not what we want to do. Hold on, sorry. It's Friday, isn't it? How about this? Let's do that. Sound good? Okay.